In the vast darkness of space, 12 billion kilometers from Earth, astronomers have detected something that defies our current understanding of the cosmos. It's not a planet, not a star, not even a black hole, but something altogether more puzzling. This mysterious object, first spotted by the James Webb Space Telescope in early 2025, has left the scientific community both baffled and exhilarated. Not only does it appear to be moving in ways that challenge our understanding of physics, but its composition seems to include elements we've never encountered before. I'm Alex McColgan, and you're watching Astrum. Today, we're diving into one of the most perplexing astronomical discoveries of the decade. A discovery that might just rewrite our understanding of the universe. The first hint that something extraordinary was happening came during a routine survey of the Bootes Void, a massive, seemingly empty region of space that spans approximately 330 million light-years in diameter. Astronomers at the Harvard-Smithsonian Center for Astrophysics were analyzing data from the James Webb Space Telescope when they noticed an unusual energy signature that didn't match any known celestial object. At first, they thought it might be an instrumental error. After all, even the most sophisticated telescopes can sometimes produce anomalous readings. But when the European Southern Observatory's Very Large Telescope confirmed the same anomaly, scientists knew they were onto something unprecedented. When I first saw the data, I thought there must be some mistake, says Dr. Elisa Montoya, lead researcher on the project. We checked and rechecked our instruments, but the signal remained consistent. Whatever this object is, it's real. And it's challenging everything we thought we knew about astrophysics. What makes this object so peculiar? For starters, it appears to be emitting energy across a spectrum that doesn't align with any known physical process. It's neither fusion, like we see in stars, nor the characteristic radiation of black holes or neutron stars. The energy signature suggests something entirely different is at play. But the strangeness doesn't end there. This mysterious object isn't following the orbital paths we'd expect based on the gravitational influences around it. It's moving through space in a way that suggests it might be responding to forces we haven't yet identified. Some scientists have even begun to cautiously wonder if what they're observing could be evidence of manipulation, though they're quick to emphasize that natural explanations should always be explored first. It's one of life's little ironies that our most cutting-edge technology might have stumbled upon something that makes us question our most fundamental understanding of the universe. Let's take a closer look at what makes this object so unusual. First, there's its composition. Spectroscopic analysis, which allows scientists to determine what elements are present in distant objects by analyzing the light they emit or absorb, has revealed traces of elements that don't match anything on our periodic table. This doesn't necessarily mean they're new elements. More likely, they're exotic forms of elements we know, perhaps in states of matter that can only exist under the extreme conditions of deep space. Some researchers have suggested these could be strange matter, a hypothetical form of matter that has been theorized but never before observed. Then there's the object's behavior. It appears to be pulsating, but not in any regular pattern that would suggest it's a conventional pulsar or variable star. The pulsations seem almost responsive to their environment. When nearby stellar winds intensify, the object's emissions change in ways that almost look deliberate rather than mechanistic. Dr. Yuki Tanaka at the Tokyo Astronomical Observatory describes it as almost like watching something that's alive. Though, of course, we're not suggesting it actually is. It's just behaving in ways that are more complex than we typically observe in non-biological systems. The object's velocity is another puzzling aspect. It's moving at approximately 0.15 c. That's 15% of the speed of light, or roughly 45,000 kilometers per second. This is significantly faster than most objects traveling through interstellar space. For comparison, the Voyager 1 spacecraft, the human-made object that has traveled farthest from Earth, is moving at just 17 kilometers per second. And while some cosmic objects like neutron stars can reach comparable speeds, they typically don't change direction. This object, however, appears to have altered its trajectory multiple times since it was first observed, something that should be impossible, without some form of propulsion. Perhaps most intriguing of all is the object's apparent size. Initial measurements suggest it's relatively small, perhaps only a few kilometers across, yet it's emitting energy equivalent to what we'd expect from a medium-sized star. The energy density is off the charts, suggesting either an incredibly efficient energy production mechanism or a fundamental misunderstanding in our observations. As Dr. Montoya puts it, either way, we're looking at something revolutionary. If we're interpreting the data correctly, this object is displaying energy efficiency that makes our most advanced technology look primitive by comparison. You might be wondering why you haven't heard about this discovery before. The truth is, the scientific community has been taking their time with this one. The implications are so significant that researchers wanted to be absolutely certain before making any public announcements. They've spent months ruling out every possible conventional explanation and confirming their findings through multiple, independent observations. It was only last month that the findings were finally published in the journal Nature Astronomy, triggering a wave of excitement and speculation across the scientific world. The discovery has naturally sparked interest. From SETI, the search for extraterrestrial intelligence. While most astronomers are focusing on natural explanations, SETI researchers have begun monitoring the object for any patterns that might suggest artificial origin. Dr. Carlos Martinez from the SETI Institute is cautious but intrigued. We're not jumping to any conclusions, but this is exactly the kind of anomaly that warrants our attention. If, and it's a big if, some form of technology is involved, this would represent the most significant discovery in human history. But what? Do we actually know for certain? Let's separate the confirmed observations from the speculation. We know that the object exists. It's been independently verified by multiple observatories. We know it's emitting energy in patterns unlike anything we've documented before. We know it's moving at an extraordinary speed and appears to have changed direction multiple times, and we know its spectroscopic signature includes anomalies that don't match our current models. Everything beyond these basic facts remains in the realm of hypothesis. So what could this object actually be? Scientists have proposed several theories, ranging from the mundane to the revolutionary. Let's explore a few possibilities. One of the more conservative explanations is that we're observing a new class of quantum object, something that operates according to quantum mechanical principles, but at a macro scale we haven't witnessed before. This would be extraordinary in itself, as quantum effects typically only manifest at subatomic scales, not in objects kilometers across. Another theory suggests we might be looking at an exotic form of dark matter. Dark matter is thought to make up about 85% of all matter in the universe, yet we've never directly observed it. We only know it exists because of its gravitational effects. Perhaps this object represents a rare instance where dark matter has interacted with regular matter in a way that makes it detectable to our instruments. If true, this would be our first direct observation of dark matter, opening up entirely new avenues for physics research. Some astrophysicists have proposed that the object could be a primordial black hole, a type of black hole that formed in the earliest moments after the Big Bang, rather than from the collapse of a star. These theoretical objects would behave differently from conventional black holes and might explain some of the anomalous observations. However, this doesn't fully account for the object's apparent ability to change direction. And then, of course, there's the hypothesis that has captured the public imagination, the possibility that we're observing something artificial. While most scientists consider this the least likely explanation, it can't be entirely ruled out. As Arthur C. Clarke famously observed, any sufficiently advanced technology is indistinguishable from magic. To our current level of understanding, this object's behavior might as well be magical. But that doesn't mean it isn't following some set of physical laws, just ones we haven't yet grasped. The next steps for researchers are clear. They're planning a coordinated observation campaign involving every major observatory on Earth, as well as space-based telescopes like James Webb and the Chandra X-ray Observatory. By gathering data across the entire electromagnetic spectrum, they hope to build a more complete picture of the object's properties. There's even talk of repurposing an upcoming deep space mission to gather data from closer range, though given the vast distances involved, such a mission would take decades to reach its target. The implications of this discovery extend far beyond astronomy. If we're indeed observing a new physical phenomenon, it could revolutionize our understanding of physics, possibly even reconciling the currently incompatible theories of general relativity and quantum mechanics, the holy grail of theoretical physics. It might lead to breakthroughs in energy production, space propulsion, or materials science. Or it might simply remain a fascinating mystery for generations to come. A humbling reminder of how much we still have to learn about the universe. As we continue to monitor this enigmatic object, each new piece of data brings both answers and fresh questions. It's a vivid illustration of how science works, not as a body of fixed knowledge, but as an ongoing process of discovery and revision. The most exciting phrase to hear in science, said Isaac Asimov, is not "Eureka," but "that's funny." And right now, some of the brightest minds on our planet are scratching their heads and saying, "That's funny," as they grapple with data that doesn't fit any existing model. The history of astronomy is filled with observations that initially defied explanation. When pulsars were first discovered in 1967, they were briefly dubbed LGM for Little Green Men, because their precisely regular radio emissions seemed potentially artificial. Of course, we now know pulsars are rapidly rotating neutron stars, perfectly natural objects following the laws of physics as we understand them. Perhaps this new mystery will similarly find an explanation within our existing framework of knowledge. Or perhaps it will force us to expand that framework in ways we can't yet imagine. Whatever this object turns out to be, its discovery highlights something profound about human nature, our insatiable curiosity about the cosmos and our determination to understand it. From the earliest stargazers who mapped the heavens with nothing but their eyes and simple tools, to today's astronomers peering into the depths of space with instruments of incredible sophistication, we've never stopped asking questions about our universe. And just when we think we've got it figured out, the universe throws us a curveball, like this mysterious object, that reminds us how much we still have to learn. As we wrap up today's exploration of this fascinating discovery, I want to emphasize that science is a gradual process. The full significance of this object may not be understood for years or even decades. It took nearly a century from Einstein's prediction of gravitational waves to their actual detection in 2015. Similarly, the true nature of this anomalous object may remain elusive for some time. But that's what makes science so exciting. It's a journey of discovery, where each answer leads to new questions, and each solution reveals new mysteries. I'm Alex, and you've been watching Space Truths. If you found this exploration of deep space mysteries fascinating, please consider supporting the channel on Patreon. Your contributions make it possible for us to continue bringing you high-quality content about the cosmos and its wonders. Hit the subscribe button if you haven't already, and click the bell to be notified when we upload new videos. You can also check out our playlist on other recent astronomical discoveries. The link is in the description below. Until next time, keep looking up. There's a universe of mysteries waiting to be solved.